Hello everyone. In this video, SMEC will be walking you through one of the most critical safety systems in offshore drilling, the blowout preventer, commonly known as the BOP. Now in any drilling operation, there is always a risk that formation pressure inside the reservoir suddenly exceeds the pressure of the drilling fluid. When that happens, the well can begin pushing hydrocarbons back toward the surface. This situation is called a kick, and if that kick is not controlled quickly, it can escalate into a blowout. That is exactly where the blowout preventer comes in. It is essentially the last line of defense between controlled drilling and a catastrophic well event. So let's start with the basics. A blowout preventer is essentially a high-pressure valve system installed on the wellhead. In offshore drilling operations, the BOP stack sits on the seabed, directly above the well, often thousands of meters below the rig floor. Its job is simple in principle, but extremely complex in execution. It must seal the well, control formation pressure, allow drilling fluid circulation. Modern offshore BOP systems are designed to operate under extreme conditions, often handling pressures exceeding 15,000 psi. When activated, the BOP closes around the drill pipe, casing, or even an open wellbore, isolating the reservoir until pressure can be stabilized. Now let's take a closer look inside the BOP stack itself. A typical offshore BOP system contains two major types of preventers. First, the annular preventer. The annular preventer uses a large elastomer packing element that can close around almost any shape inside the well, drill pipe, casing, or even an open hole. Because of its flexibility, the annular preventer is often the first barrier activated during well control operations. Next, below the annular preventer, we have ram preventers. These are more specialized devices designed to close the well under specific conditions. Common types include pipe rams, seal around the drill pipe; blind rams, seal the well when no pipe is present; shear rams, designed to cut through the drill pipe and completely seal the well. Shear rams are considered the ultimate emergency barrier in well control operations. If everything else fails, they physically cut the drill string and isolate the well completely. Now here is something many people don't realize. The preventers themselves are only the mechanical barriers. What actually makes the BOP function is the control system behind it. Commands typically originate from the well control panel on the drilling rig. Those signals are transmitted down to the seabed through multiplex electrical systems or hydraulic control lines. Once the signal reaches the BOP stack, it activates Subsea control pods, which direct hydraulic power to the appropriate preventer. Key components in this system include hydraulic accumulator units storing high-pressure energy, control pods and solenoid valves directing hydraulic flow, multiplex communication systems, emergency shutdown circuits. All of this ensures that when a well control event occurs, the BOP can respond within seconds. Interestingly, in many incidents the problem is not the preventer itself. The failures often originate from the control architecture around it. Common causes include hydraulic pressure loss, control pod malfunction, signal transmission faults, accumulator failures, instrumentation or sensor issues, which is why continuous testing, monitoring, and maintenance of the control system is absolutely critical, because the reliability of a BOP system ultimately depends on the integrity of the control and monitoring systems behind it. As offshore drilling becomes more complex, well control systems rely not only on mechanical strength, but also on advanced automation, instrumentation, and monitoring systems. At SMEC, our engineering teams support offshore operations with BOP control system integration, automation and instrumentation support, installation and commissioning, diagnostics and maintenance of critical well control systems. Because in offshore drilling, reliability is not optional.